Another type of problem that you're likely to see on your test is one involving geometry, area, volume, and length using calculus. You learn two different area formulas. One is for rectangular and one is for polar. In rectangular curves, the area under the curve is just the integral of f of x times dx. And the reason that's the case is you can divide this into infinitely many skinny rectangles. The height of the rectangle would be f of x, and the width of the rectangle would be dx, a little tiny change in the x-coordinate, and so you're finding the area of a rectangle. So that's why it's so straightforward. Polar is different. Polar, you're not finding rectangles, you're finding little segments of a circle. And so that's why it's this other formula. You're finding little pieces of pizza. Just to kind of emphasize why that is, imagine that you have a perfect circle and you want to find the area of a piece of pizza. You want you would take what percent of the pizza you have. So theta over 2 pi would be the entire length of the circle. And then you would figure out that times the area of the circle. So it's like, what fraction of the circle do you have? So times pi r squared. The r's wind up canceling, and so that's why this is r squared, because you're taking the radius squared, and actually this theta is your little tiny change in theta. So that's also why you have a 1/2. So that formula is how you find area in polar. It's not just doing the integral of the function. Then we learned about finding volume. Finding volume when you have cross sections that are a known shape. You want to find the area of each of a single cross section. So you draw like a single cross section and you figure out the area of that cross section, and then you multiply it times dx, because the area of a prism is the volume of a prism is the area of the base times the height. So this is the area of the base of a prism, and dx is the distance between the bases, or the height of the prism. And that's how you find the volume. The tricky part is figuring out the area formula for the base. I think they'd give you an area formula for an equilateral triangle. I don't think they'd give you an area formula for an isosceles right triangle. So be comfortable with those formulas. This is also, if you're perpendicular to the x-axis, that means that all of your functions should be solved for y, so that you have x's in your answer, because then you'd have a dx. If you're perpendicular to the y-axis, then everything should be solved for x. You should have y's in your functions, and you should have a dy for a height. We also learned about revolving regions around the x-axis or the y-axis, or even a different horizontal or vertical line. If you're going around the x-axis or any other horizontal line, then you would have dx's, and so all of your functions should be solved for y, and they should have x's in them. Because you're taking the volume of a single washer, you want the area of the base, which is going to be the big circle minus the little circle, and then times the height. So this is the radius of the big circle squared minus the radius of the little circle squared, because you want to take those areas away. This is not the same as doing the radius minus the radius and squaring it. You want to square those separately. You don't want to subtract and then square. You're squaring them separately because you're trying to take away area. You're taking away this area here. And then we also learned about arc length as our geometric topic. In rectangular coordinates, you take the derivative and square it, and then you do the square root of 1 plus the derivative squared, and you do the integral of that. We talked about why this is. It has to do with the Pythagorean theorem. With parametric, perhaps the Pythagorean theorem is a little bit more obvious, because you take the tiny change in x over time squared plus the tiny change in y over time squared, and you take the square root of that, and that gives you your arc length. So those two arc length formulas should be comfortable for you. Right, that is the area and volume topics for calculus. Thank you.